Hello everyone, warm welcome to today's video, and today we're going through 6 of the questions from instrumentation, and more specifically the electronic displays or integrated instruments of this ATPL topic. So if this is your first time, then warm welcome to the video, and if not, then I hope this will be quite useful. So as always, I'll give you 10 tips for the exams, and we'll explore the topics and the explanations in a bit more depth. So without any further ado, let's jump into question number 1. So after a failure, an appropriate procedure for following an on-screen checklist uses which of the following? So of course, we have the ECAM and ACAS, ECAM for the A320 or Airbus generally speaking, and the ACAS for the Boeing. I cannot really speak for the Boeing as I do not fly them. However, I can tell you about the Airbus, which will follow the exact same procedure that EASA wants you to remember. Generally speaking, whenever you get a warning or a caution, it will call for something called ECAM actions, meaning one of the pilot monitoring will begin the ECAM procedure. What he needs to do first and foremost is to confirm the failure and silence. So for example, if you get a engine fire 1 warning, the pilot needs to check that the engine at the top panel is actually on fire. If that is so, then he can continue with the ECAM procedure. Now, of course, going down, checking the status of flight warning system. No one ever does this. This is one of the key things. The flight warning system has a test that will be done before every flight of the day, and it is vital that you as pilots always trust it and believe it, because otherwise, or ignoring it, can lead to extremely dangerous situations. So you never really check the status of the flight warning system during any alarming situations. It will be tested, however, before the beginning of the flight. Follow the checklist slowly and methodically. Of course, seek confirmation prior to manipulating any guarded switches. Absolutely, you need to ask confirm the other pilot, as well as for the thrust levers and the engine masters. So any actions that are irreversible, so these will also be guarded for the same reasons. For example, the IDG, the integrated drive generator, is guarded because it cannot be restarted in the air anymore once it's shut off. And lastly, assess the possible implications of making certain selections. This will always be last. In the Airbus, for example, after you complete the electronic checklist or the ECAM, you will then move to status. The status will tell you everything about what has changed and what is different and what implications there are for shutting down certain systems. So this status page is always last in the ECAM procedure. So of course, initially, you confirm the failure. Then you would go into seeking confirmation prior to manipulating any guarded switches. Of course, if you follow the checklist so methodically, first thing, you might miss this. Always make sure to never do any irreversible actions without confirmation. And then we go into following the checklist and lastly assessing the possible implications. The key for answering these questions is to remember that checking the status of the flight warning system doesn't make any sense, especially for the failure. You need to make sure that you as pilots trust it and follow it rather than question it if there is something burning happening to the aircraft at the very moment. And now going into question number 2. What is the certification type of EFB systems, which, in the case of failure, causes a minor impact on safety? Very straightforward question, however, it can be your easy point during your exam. So there are just 2 types of different EFBs, the type Alpha and type Bravo. So these types mean essentially that one of the types causes some little or minor implications on safety, and the other one does not at all. So, of course, there is a mnemonic, as it is with many things in aviation, that I highly recommend you remember for these questions, and it will be as follows. And of course, it is type A for all good, and type B, bit of a problem, meaning type Alpha EFBs, they have no implications on safety, all is good no matter the status of it, and type Bravo, so bit of a problem, these can cause some minor impacts on safety. These in most cases will relate to your portable and your built-in EFBs. So for example, an iPad, if it breaks, it will cause absolutely no safety issues to the aircraft. However, if we have a built-in EFB, it can be an MEA item and cause some implications on the safety and the safe conduct of the flight. So this is something to remember. And lastly, remember this key thing about the EFBs in general, and remember the rule that EFB, which is the electronic flight bag, will never send anything to the aircraft. Always the order and the priority of the information sent is from the aircraft to the EFB and never the other way around, because the EFB is not an FMS, it's not a system that can guide the aircraft. It is for us to calculate, for example, performance and cross-check other important data. So of course, minor impact on safety, type B, bit of a problem. And now for question number 3. An EFIS includes the following components. So the EFIS is our electronic flight information system. The EFIS is essentially your basic six-pack, so your balance, turn coordinator, altimeter, airspeed indicator, vertical speed, so anything you have in your basic six-pack. However, it's put inside of an electronic display to give you all information at once. And of course, there are quite a few components of these, which I'll show you in just a second. So just to visualize it, the modern aircraft will have the EFIs that are very, very advanced and can show you many, many different things. So here, this is a cockpit of the Airbus A320. So you can see the EFIS display is right here and also includes the ND. It gives you all the information needed about the safe conduct of the flight. However, there's also your EFIS control unit, which is right here on the Airbus. So this square here, which also includes the QNH and standard pressure setting unit, this controls the displays of your navigation display and your EFIS in general. So you can change here from different EFIS modes, such as the Rose LS, Rose VOR, your nav displays, your ARC, and your plan modes in the Airbus. They have slightly different names in the Boeing, however, they do generally the same thing, as well as the ranges, the VOR or NDB selections, as well as the displays on ND, such as in Airbus constraints, waypoints, VORs, airports, and other things that could be needed throughout the flight. And generally speaking, this right here is your EFIS control unit. And then, of course, in the middle, we have our autopilot panel that we use to fly. However, this right here is the control panel. So going back to the question now, of course, it will be much easier to answer the question. We have the symbol generator, such as the VFE speeds that are changing, your green dot speed, so your best lift your to drag ratio speeds, your flight directors if selected, as well as, of course, we have the display units that display the information like the altitude, etc., and the control panel that we have just seen a second ago. And now for question number 4, the primary flight display, or the PFD, displays information dedicated to, and of course, the PFD, the primary flight display, as it says in the name, it gives you information dedicated to piloting. So the PFD gives you the basic 6 in the configuration of the standard T. So we have all the most important information about our speed on the left, about our altitude on the right, about our heading on the bottom, and about our attitude of the aircraft, so the pitch, roll, bank, etc., in the middle, as well as where the flight directors are. You can fly safely the aircraft without with only the PFD, because this is what we use to pilot the aircraft. It is the same in the Cessnas and the small GA aircraft, as well as the biggest Airbus or Boeing aircraft. We use the PFD or the basic 6 with the T in order to get to the most important safety critical information. And now going to question number 5. So list the typical equipment of an EFB. So your EFB, of course, there are plentiful EFBs. In most cases, an EFB will be nothing different but a standard iPad with certain performance information and applications on, so you can use it to cross-check some different maps of the airports, to calculate performance calculations, etc. However, as we already discussed, remember the flow of information is always from the aircraft to the EFB. So you take the information from the aircraft to the EFB, and you never update the aircraft with this information, at least automatically, because of course you do not want to feed your aircraft with some information from the EFBs that might not necessarily be qualified for these reasons. And of course, going from these lists here, you can already spot the MCDU. MCDU is your panel to talk with the FMS, Flight Management System, and this is where we put all the information about the flight safety, the performance, the flight planning, etc. But this is our way of talking with the aircraft, and this is absolutely not a part of EFB. This is a much different system. Tablet, in most cases, yes. Integrated avionics suite of an aircraft, it will absolutely be the part of an aircraft, as well as a laptop. Not anymore. I haven't seen any laptops, however, it absolutely could be an EFB, the same as any other electronic unit. The integrated avionics suite of the aircraft is where things can get a little bit tricky. However, this is why I wanted to show you a picture of a cockpit of the Airbus A350, and here highlighted with the red squares, you have the integrated avionics suite, which is part of the integrated EFB, and this is also the Type Bravo EFB that we already discussed, the one that can cause a bit of a problem if broken, because if this is broken, this could be an MEL item, meaning it might pose some limitations to your flight mission and your flying. These screens can help you calculate performance. These can help you navigate the aircraft, show you some different charts and other things, the same as normal EFBs would do for people who use, for example, a standard iPad. And now going into the last question, so question number 6. Which option correctly lists the modes of a typical navigation display? Very straightforward question. However, as I already mentioned, they are a bit different for Boeing and a bit different for Airbus. However, they will generally provide you the same functionality. So you have the map or arc, which you will use to generally fly the aircraft. This is the standard one that gives you like a pizza cut of the compass to your nearest headings. VOR or Rose VOR, this one will be used if you fly a VOR approach. Then you have the Rose LS, absolutely no takeoff, my mistake. Then you have the approach in Boeing and Rose LS in the Airbus, which shows you your localizer and glide slope with a lot of precision, as well as the compass rows all around it. This will be used for your raw data ILS, as well as the plan mode, which shows you the north at the top, no matter your aircraft orientation. This one is used usually to cross-check your flight plan and make sure everything is coded properly inside of the system, or just see where your route is taking you, with the north always pointing towards the up point. And this will be everything for today. So thank you so much for joining. As always, if you have any questions, feel free to ask them in the comments. We'll do our best to answer. And until then, we wish you all the best. I hope you pass your exams with flying colors. And until the next video, have a fantastic rest of the day, and bye-bye.